One way to calculate the vertex and line of symmetry will be focused on this first screen, and then we'll focus on another method on the second screen. I have bolded in the directions what method this is going to be. So we are going to set up a table. Again, not the only way. This is one of the ways. So if I make an XY table, we typically hover right around the origin. So I'm choosing X values to plug in. From here, I'm going to go ahead and plug these into the equation. So just to show you what I'm doing with one of them, I'm taking this and I'm plugging -2 in for all of the X's for our first entry. And then we'll go through and do the same with the rest of them. So this would give us 4 plus 8 plus 3. I believe that is going to give us 14. So we go through and we finish this process. So fill in the rest of the table. Based off of the input that I have, it doesn't look like I have actually found where my vertex is located yet. So I would extend this and plug in some additional values. I do see that it is following the pattern that I would expect. You'll notice that the Y values are now shrinking and getting lower. Okay, there we go. So we did find where that duplication starts happening here. Once you start seeing that duplication, we know that we could use symmetry. So I do know without actually plugging in the next value that the 4 would match with the next one, which would be 3. But since I am looking for the vertex here, the vertex is going to be the lowest point in the table. So if I take a look at the table itself, I see that the lowest point, so the one that has the smallest Y value, is going to be located at 2, -1. That is going to be my vertex. Now, continuing on with this, if you want to find the line of symmetry, the line of symmetry is the X value of the vertex. So you don't necessarily have to find the Y value, but you do have to find the X. You notice that this question is the same as the previous one. So if I go back to my vertex above, I know that my line of symmetry, again, is a line. In this case, since it is a Y equals parabola, which means the parabola will either open upwards or downwards. It is vertically oriented. Since it is vertically oriented, then our line of symmetry is a vertical line, which is always X equals. Go back to the vertex, take the X value of the vertex. That is going to be our line of symmetry. Another way to calculate the vertex is to actually calculate it using the X-Intercepts, if you can locate them. So go back to what we did in a previous video. We would set 0 equal to Y. Now again, multiple ways to do this. One way would be to factor. If you need to work on factoring, look at the previous videos for that. We know that this factorization is going to be X minus 9 and X minus 5. Using zero product property, we know that this is going to be X is equal to 9. And we know that this is going to be X is equal to 5. We're going to use those two X values and we're going to average them. To average the X values, we're going to take the two X values, we're going to add them together and divide by 2. This is going to give us the X value of the vertex. But that does not finish the vertex for us. We still have to find the Y value that goes with this. So we go back to the original equation, and everywhere we see an X, we're going to plug in a 7. And calculate this Y value as -4. Now we know what the vertex is going to be. Take the X value that was the average, and then take the Y value that we calculated after plugging it in. That's going to be the location of our vertex. Additionally, to be able to do the line of symmetry, we would go through the exact same process. You notice these questions are the same. We know that this is a vertically oriented parabola, which means the the line of symmetry is going to be x equals, and we take the x value of the vertex.